All right. I will be presenting a video, so get that. There we go. And can everybody see that? All right. Let's go.
Hello, my name is Bryan Weiss, and I will be presenting my senior capstone project titled Microphone to Music. So, the problem I wanted to solve was notating music takes time and musical ideas happen fast. What I mean by these two things is when you're coming up with music, ideas can happen in the spur of the moment, and you want to be able to record them as soon as possible as to not lose the original idea. And writing this down physically on sheet music takes a lot of time. It takes some musical knowledge to begin with as well. And in this time that it takes to record it, sometimes your original idea is lost. So I was wondering if these two things could be done at the same time with some sort of software that records you while playing or singing or whatever and prints it right to sheet music and saves it immediately in its original state. So I set out to do some research on how this could be possible. I found that some solutions do exist. Finale and Studio One both have a feature in them that allows you to record small bits of playing and print them to sheet music. Now, unfortunately, both of these cost a lot of money, at least $100 for the base package of the software. So I thought maybe I could make this more accessible and maybe make it a bit more to how I thought of it as the core idea of the project, rather than being a tacked on feature of a notation software. So I found that many programming languages do support audio processing: C++, C Sharp, and Python, just to name a few. And I researched to find which one of these would be the best for my purposes. Easy to use, easy to learn, good support was what I needed. So I decided on Python. Now, with Python, I unfortunately had not had a lot of experience aside from a few projects here and there within Carthage's courses. But two reasons really drew me to it: Aubio and PyAudio, which are two packages that support audio processing. But Aubio specifically supports audio processing for music-based applications, which was great to hear that I didn't have to figure out a way to slice music out of just .wav file. Both of these packages also had great support, documentation, examples, community forums, which I used extensively throughout my project. So I've used the term notation software a few times, so let's talk about it. So it's computer programs that allow you to write music at its core, and but there's a lot out there, and they have a lot of different fancy features. Some of them let you listen to the music you've written back in MIDI, or even better recordings of it. Pretty much, it's an idea to allow anybody to notate music, since traditional pen and paper takes some knowledge to be able to do accurately. So for my purposes, I wanted to either make a program that was a plugin to one of these softwares, or write my own basic notation software that was bare bones, so that my program was the center feature of it. So I needed something that was simple and ideally open source so I could easily modify the code. So through my research, I came to LilyPond, which, calling it music notation software is kind of difficult since it is so bare bones. From LilyPond's website, it is a compiled system run on a text file describing the music. So, really, it's music notation through coding. As you can see on the right, that's what some LilyPond source code looks like. And it is being typed on there by using the text editor that it's downloaded with LilyPond when you install it. Now, it's really just a notepad window with a few more buttons on it to actually save your sheet music. But I thought that this was perfect. I was coming up with a plan in my head to output LilyPond's source code, but after analyzing some audio. I figured that's much easier than trying to figure out how to write a plugin for a complicated music notation software. Just being able to run LilyPond off of a window would be perfect for my uses. So I came up with a better plan than just what I was going on in my head. I wrote it down. I was going to use Python and LilyPond together to complete this program. So PyAudio and Audio would record and analyze the music. I would write code to convert the analyzed music into LilyPond source code, and I would allow the user to control this whole process through a tkinter GUI, which is Python's default user interface package. So I thought that was an excellent plan, and I dove right in. But I encountered a lot of problems. So first of all, outside of that original plan, I didn't really do any planning as far as how to go about it, how to write the program, at what pace I should do it, and what it should look like when I'm done. I just kind of figured I would know it when I got there, which was a very bad assumption. Second problem was my testing. It took a lot of time to test, and the accuracy of the test I was doing at first wasn't very good. I was just recording whatever I could and getting tons of different results since there was a lot of variance in what I was recording. Now, the last two are things I'll get to a bit later, but I'll just briefly mention them. The harmonic series is a music theory element that really came into play while I was trying to set up this program. Then finally, multiple loops and multiple threads. So this is a programming thing that I will get into towards the end of my presentation that really threw me for a loop, no pun intended. So let's talk about how I went about solving these problems. So first of all, I went about planning a lot better. I set goals for myself as far as how much work to get done and what I should get done. So I kind of was just trying to tackle everything at once as opposed to just setting smaller chunks of work to get done throughout the time I was working on it. Now, this helped me a lot by not getting burnt out and being able to look back at my progress as opposed to just looking ahead to how much I had to do. I also scheduled my work a lot better. At first, I was just doing the work anytime I could for days at a time. It would be all I worked on, and that was very easy to burn myself out on. So instead, I scheduled days and times during those days that I would work on just my project, and then outside of those times, I would not work so I could look forward to the next time I would work on it and reflect on what I was able to do during those times. So next, I had better testing. So initially, I decided to actually hardwire input from audio files that I found online. Because at first I was just using live input the program wasn't ready for that. So I realized that pretty quickly that I needed to figure out another way to test it. And I'll actually demo that right now. So currently I have my program set up in the state that it was when I was doing this. There is a hardwired input of hot cross buns loaded into the program directory. Now, I'll play that quickly just so you get an idea. And you get the idea. It's hot cross buns on a very simple piano. So, normally you would record and stop the recording if you're doing live input, but right now it's already hardwired into the program, so all we have to click is generate LilyPond. So this is the LilyPond code that is then able to be edited within the program itself. You can see that there's several lines of LilyPond code possible to be edited, so if any mistakes were made while recording, you can simply edit them after knowing a little bit of LilyPond, which is pretty easy to learn. You can then save the LilyPond. It is located within the project directory, so you can access it at any time. And finally, you can view the sheet music. So here's hot cross buns written on sheet music. You could see that the other options would have allowed you to change the time signature and the clef located up here and here. The recording I chose for hot cross buns was in 4/4 and in treble clef, so that's what I left them on the defaults. But yeah, that's how hardwired input ended up getting tested, and I realized that I was actually processing and listening to music with my program. So let's get back to the presentation. So eventually, I switched from that hardwired input to live input from a recording still. So on my phone, directly into a microphone, playing that recording of Hot Cross Buns and eventually other things as well to diversify it. Then finally, I switched to true live input, which I will demo at the end of the project. But I was able to use a microphone, record both guitar and piano pretty accurately, as well as several other instruments with varying degrees of accuracy at this stage. And then also, anytime I added new features, I would fall back to previous stages if I noticed the testing was becoming inaccurate again or not what I expected to see. So, let's talk about the harmonic series. So, pretty much, to simplify it, when you hear a note, oftentimes you'll hear the fundamental frequency, which is the name of the note most of the time. But what you're actually hearing as part of that note is several other tones that are a part of it. It's physics more than it is anything. As you can see on the graphic on the left, you can see how there are several notes within the fundamental C frequency that you might not be able to perfectly hear. And that on some instruments, that's more apparent than others. So a recording, of course, will have pretty filtered out harmonics, especially a digital recording. Piano often will, the harmonics are not that easy to notice. Now, my main instrument is bassoon, which is a double reed instrument, part of the woodwind family, that is pretty notorious for loud harmonics. And it was very difficult, if not impossible, to actually get a good recording of it work through my program. So my solution with this was really just filter the crap out of the recording to try to reduce the series and just hear the fundamental. But unfortunately, with instruments like the bassoon, occasionally other frequencies within the series are actually louder than the fundamental just by the nature of the instrument. So, multi-threading. So I realized pretty quickly when I started working with the user interface that I was going to have to use this eventually. I realized this because tkinter, the user interface with Python, runs inside of a loop within the program. And my recording function, the function that actually loops the ability to record, is also in a loop, and you can't do two loops at once. So I realized at the time, through Professor Kowalowicz's operating systems class, that two loops can be done at once, but they need to be done by multiple threads. And this was a very difficult process. It was a lot of trial and error, especially when I came to the point of I needed to terminate threads on command rather than letting them run their course. But I eventually got it right. I am able to run the user interface within a window and record at the same time by using multi-threaded programming. So at this point, I will demo my final product to you, and then afterwards I'll talk about some reflections I had through this process.
All right. I will now demo my program using live input from the piano. So, as you can see, or not see, but as you can hear, I'm at the piano. I've just come up with this brilliant idea. Uh, it's gonna sound pretty similar to Hot Cross Buns, but let's record it anyways because I want to be able to see what I did later. So I will hit record. Yes, I want to do that. All right, stop the recording. Now, through talking and all of that stuff, I will preface that this won't be perfect, but luckily we'll be able to edit it and the core idea will still be there. So let's generate the lily pond. Let's make it a bit easier to read. Now, this is always going to be kind of ugly, but let's save it and let's view the sheet music. So, this is probably a bit worse than it normally is. Well, it is a bit worse than it normally is. Because I was talking so much. So this was it trying to understand what I was doing while I was talking. But as you can see, these notes, that's still hot cross buns. So let's change some of this. Let's actually bring up both of these to make it a bit easier. So the first actual note of hot cross buns is going to start on that E. So you can go ahead and delete all of that. And then it ends on that C, which is here. So you can go ahead and delete all of that. Save, view the sheet music, and there's your hot cross buns.
All right, and then I figured I'd do my reflections live. I thought it would be a bit easier, but I'd just like to thank the Carthage Computer Science Department, specifically Professor Kovalowitz and Professor Mahoney, who I had a majority of my classes with over my time at Carthage. I would not be nearly the programmer I am now without both of you. I'd also like to thank the music department at Carthage for continuing my love of music throughout my time here and allowing me to combine it really with my major without having to pick one over the other. And I'd just like to thank my friends and family, and specifically my roommate, who was able to listen to me swear and cuss throughout the night while working on this project. Thank you. Any questions?
So questions for Bryan?
Yeah, I got one. So as a fellow woodwind player, I play the tenor sax. I know it's really hard to get in tune, and a lot of different factors can change how your pitch and stuff. So did you have any trouble accounting for just the guy playing, or like you said you were playing the bassoon, like the guy just being off? Like I know that's not really an issue for the piano, but
Yeah, well, I did actually have issues, and the piano that's in the basement of the Oaks that I was actually recording on was a little fickle in some of the registers of it. But it does require you to be relatively in tune. There is with the audio package for telling notes, getting notes. There is I think Bailey actually mentioned it in her presentation, but a confidence interval. So there's room for error, but it does require the user to be relatively in tune, and also within the 440 hertz tuning system, which is the kind of Western style. If you go elsewhere in the world, you might find other things. So unfortunately, this program might not work in places in like Asia where they use like 442, but it does require to be somewhat in tune.
okay, thank you.
Hi, Brian. I'm wondering a little bit about the, I guess, the Python packages that you were using.
Sure.
So you mentioned there were these, multiple threads, one for the GUI, and then one for the listening part of the app. And I'm assuming those two threads didn't really share any data. Is that right?
No, the thread was just the thread was run when you hit record. It would just I like kind of custom built a class for these threads since um I couldn't like terminate them on command. So then I kind of just I don't think it's might be best practice, but I just hardwired kind of it to run just that recording function that I had within my recorder class. So no, there is no data that's actually shared between these threads.
Yeah. So that's probably good because that's the hardest part when
Hmm.
you have multiple threads. But speaking of multiple threads, I was thinking, or I guess I'm wondering about the software that you used. If, for example, you had two people playing different instruments, very different sounding instruments, if maybe you could create sort of multiple threads that narrow in on a particular set of frequencies and basically do this, times 2 or 3 or 300, um, could the libraries that you're using, could they do that? Could you imagine how that might work?
So I did originally, I defined it actually in my thesis proposal, have a stretch kind of a want to possibly handle like chords, which would be kind of what you're talking about. And unfortunately, with Aubio, it can really only do single note detection. I could imagine eventually getting to the point where you could pick apart frequencies, but then again you would run into that harmonic series issue where one instrument might actually be playing multiple frequencies at once, so you might run into error there when trying to pick up apart a chord. I in those other software things that I researched, like the Finales, the big one, I don't believe even it can really do chords. And it's like a $500 piece of software. So it's something that I think it's trying to be solved still.
It's a really, really hard problem.
Hmm.
My last question is just about the generating the, looks like you made a PDF of the sheet music.
Yes.
Was there a tool that did the Lily Pond do that, or did you do that?
So that was that came with the Lily Pond. It's kind of like compiling it almost. It just opens it in your default PDF, but I just the only code that I wrote as part of that was calling that function from like the Lily Pond when you hit the like generate PDF button. It was kind of difficult because you had to then give the program the like sort the directory location of where you downloaded LilyPond, so it had access to that code. Um, but it was it was actually trickier than just generating the PDF. But yeah, it was LilyPond that did that pretty much.
Because I was wondering if maybe if you built some sort of web interface, might be neat to like actually be able to edit if you did some sort of web thing, edit the notes and have that sort of be reverse or forward and backward editing both in Lily Pond and on the web.
Yeah, I was when I originally set out, I was hoping to have a more in-depth like notation software where you could just click on the staff and drop notes and such. But it turns out those not a lot of those exist that have like easily modifiable code bases. And Lily Pond just kind of presented itself as this weird niche thing that was perfect for my uses. So I just kind of rolled with it.
Cool. Yeah, I think future students, you might want to mention there's some potential to build off of what you built. So
Mhm.
cool.
Thank you.
Very cool.
Okay, some more questions for Bryan, please.
So those Python libraries, Aubio, and I forget what the other one was.
Pi Audio.
So what is using those libraries look like to analyze live recordings and the hard coded?
Sure. So with Pi Audio, pretty much all Pi Audio was doing was the actual recording. It just had like a couple of built-in functions where you could set like the sampling rate, the certain aspects of the recording, but that would then they kind of like told you how to run it in a loop, but you had to implement it yourself. And then that is then saved when it's knows it's done recording as a like .wav file in the directory, which I then pass to Audio, which specifically is only able to analyze .wav files. And I picked it apart using different functions. I used the note name function so that I could easily translate that to LilyPond note names, since there's specific syntax for that. The note length function, which was an audio thing where I had to loop through the recording again to find each note length and keep track of what note names had what note length. And then finally, I actually had the most trouble with the get beats per minute function, which I then had to use for the note length because it had to know the timing of the piece, which every time I recorded it, I actually had a little metronome going in my ear, so I was as accurate as possible. But pretty much when I would hardwire the code, I just would give the function that ends up going across and doing all those different analysis stuff. I just gave it the name of the .wav file that I had put in the directory myself, as opposed to creating the .wav file, saving the name of it in a string, and then feeding that to the function.
So Brian, what platform did you use for development?
I used JetBrains PyCharm
Windows, Linux, Mac?
on Windows.
Will it work on Mac? You know, is it a wonderful Python thing?
I haven't tested it, but it might.
It might. It's Python.
Yeah.
Yeah. Okay. Anybody else have any questions for Brian? Good work, Brian.
Thank you.
That was good work. Let's give him a round of emojis.